All right, let's start here. All right, I go to download one of these kinds of called Epic Pen, making it a little bit easier. I don't necessarily go to the Zoom. Earlier, I go to the Zoom to use the notepad, right? Note. So this one a little bit easier for me. Now, okay, so last week, week 7, we learned some new, actually pretty high container. This is prepare for level 2, but sometimes also pretty much show in the SAT, general SAT. Nice. Okay, so the topic a little bit challenging, but if you finished algebra 1 or pre-calculus, I believe you already learned this part. So composition of function, actually, we just need to learn this one. This one is a little bit a description of this one, right? And have several different kinds of expression. They have a sequence. Be careful about sequence. And they can describe this way or describe this way. You can see that they put a front here or get rid of these parentheses. So they have sequence. Who do the first? It's important. So looks like I can imagine this one. This one is better to understanding, right? So you have initial kind of function. First function is here. And put this function became a variable of another function, right? So this is better understanding. And so the sequence here cannot be switched, right? Like we do the product A times B equal B times A. Here is when they do the function part, you cannot switch the position. You know that one, right? When they are switch position, the result is totally changed. So the sequence is important here. Okay. The second one you try to define, make sure you know the scope, the scope and domain, right? The domain and the scope. The domain, just like try to make sure this one, whenever the data come out here, to make this one reasonable. You cannot make this one undefined. So make sure. So, all right. So this one composition part, and I don't like to repeat it here. And this one would be some of the formulation, some of the examples. And second one we call recursive formula. Recursive formula, just like they are happened recursive formula. So it means it's a previous sequence, just like the data is a similarity like earlier, just continue earlier one. You know the clear this one, right? Just this is previous one, so f equals gx here. So this part actually is from previous one. You can see here, it actually is like a previous one. So this one's initially fx. So related here, you can see everyone is continue using. So all the terms, just like they have a series data from A1, sometimes the beginning A0. So it's called first term, the second term, right? And third one, continue, move on. And the one always related to the previous one. When you go to college, you maybe can see these kinds of series, like something like that. Let me give for example. This one is related to previous one, right? Sometimes they related to two of them. You maybe met these kinds of series. Say 1, 0, 1. And the third term is the sum of the front two terms. So like the third one still 1, because, and the third one will be 2, like 1 plus 1. And fifth one will be 3. And next one will be 5. And next one will be 8. Something like, say, AN in is equals to like this one. So it continue became 11. This is very famous kind of number series. So it's growing much quicker and quicker. Right? Initially, just like keep same, it became slowly increasing in in these kinds of data, this series data. And I know in some area they are very useful. And another one, you maybe learned another kinds of example before. I thought it's an Indian story, legend story. And one farmer talked to the king. He said, I want to put one seed here. So each next one just filled with the number is double like previously one. So AN equal 2 times of previous one. This kinds of feeling. And there's a lot of frame. They about 64, I think, time to 8 to 8. So farmer go to talk to king, something like this kinds of story. I don't know if you guys have ever heard this one. They went to the king, he asked a request to the king, say, I just need a number. The number is, put the first frame, put one seed, and second one is double of front one, and then fill all these format, these kinds of frame. And then that's it. The king say it's so easy, right? But finally they figure out the last number. This number is really huge. You can imagine here is 1, here is 2, here is 2 times 2, so it's 2, right? Here is 2 times. And so here, when you goes down, here is 2, totally 16, right? 2 power 16. This is a huge number. If this number goes 64, 2 power 64, even one seed is 1 gram. You can imagine how many grams here. When you transfer it, how many times. So that means a lot of rise was totally here. It's not so simple. So number growing, when it initially grows so small, right? But when finally it grows dramatically increasing. Similarity, the kinds of story you maybe heard before, but it's an interesting one. Sometimes they use it in reality, right? And now the example here we talked before, right? If you goes to, you can review the videos as well. Okay. Right, let's go see more. What did we learn last week? Did you guys do this one as homework? Yeah. Okay. All right. So, I think someone's still joining. A little bit late. Okay. Someone talking in the sorry, in the chat group. No. Sorry for that one. All right, let's go down. Continue working on this one. So this is repeating, right? Just like repeating, like this is the first term. This is the first term, and keep second term and then third term. Keep it going on. And so it will be just like replace. So you need to get this part first, and then get second part, and then get third one. Right. Okay, so let's an example there already. Do you guys need me to repeat this part one more time? Someone have any confusing? No? Everyone's so quiet. Please bring the question. Whenever you're not clear, bring up. Okay. Let's make everything clear, make you understanding. All right. And this part, the same thing is, you can see the example of here. The quick see the question here. You can see this part. Each year, I think this is deposit, right? Each month they give 0.5% increasement. Each month have 0.5% increasement, and then put the additional 200 here. So you can see A0, and they have to give A0, right? Or A1 kind of thing. So you can beginning the first term, and then you can continue to do the rest. You can calculate, get the rest of the terms. So that's pretty easy to understand, right? All right, let's move on. That one. This is multi, still have the same situation. So let me, I don't know, this one, all one was clear. Let's do this one more time. Okay, that's a little bit complicated case one more time. It's not still in the waiting room. Okay, Abby, a little bit late. But it's okay. We just begin not too long time ago. Okay, so let's see this one. Okay, so this one, A N is right here, like three of them, right? So they give the initial, and Fn was defined, Gx also defined. So A0 equal 1. So we can got A1. A1 equals what? A0, right? G A0. So like this. So early when there was 1, so all replaced by N, all replaced by 0, right? Okay, so we can replace here. So F1, we needed to put 1 minus 3, right? 1, just replace here, 1 squared minus 3 times 1, right? This is Fx. And G here is 2 times 1 minus 3. Right? So you can get. So sometimes you can just make it easier. Just put all this one replaced by x squared minus 3x. And this one just replaced by the 2x minus 3. Right, one step. And x just like A0. A0, you can use the previous one here. So 1 minus, yeah, negative 2, right? Here is negative 1. Right? So you got negative 1. Right? Here is 2 minus. Is it correct? All right, so A2 is A1 minus FA1. So FA1, so A1 squared minus 3A1, right? 2A1 minus 3. So we just replace negative 1 here. Negative 1 squared minus 3 times negative 1. 2 negative 1 times, negative 3. So you can get it here. So you can calculate this part, right? So we get a negative 1 minus 4 over, yes, 4, right? Over negative 5. It became positive, right? So it became, oh, yes, go somewhere wrong. This part, right? So just make it a little bit complicated, not so challenging, right? Right, let's move on next one. So exponential function, actually exponential function, we learned this before, right? So I just like earlier we have the example, I told the example. So exponent, actually the x, the variable is changed from, you can imagine here, just like say, so we learn x power n, right? Like this one. And we x power n times x power m, this kind of exponential. So this is number, this is constant number, and this is variable, right? So we know this kinds of thing can get the variable at the base, and the exponent part is constant number. When I do this is the product rule, right? This is the quantum rule, right? And we also zero rule. If this one not equal 0, this one always equal 1, right? Also, we have what called product power rule. So if they have multi-factors, they can each of the factor power, right? If they is fraction, they also can be transferred like this, right? Each of the numerator, denominator need to be powered by itself. So this is basic rule for algebra 1. We learn this part. So this one will be transformed. You can do a lot of transform. So right now we do a little bit deeper here. So exponential function. So right now you can see here is the x is in the exponent. When you do this kind of, so this part is constant and this part is keep changing variable, right? So we can quickly do some examples here. So if they are, so if A A definitely will make it positive first. We'll see the positive part. So if A equal 1, you can see fx equal 1 power. So 1 doesn't matter x is what, they always equal 1. Right? So when you're graphing, whatever x will be, y always equal 1, right? So this one is 1 power x. So when x in between 1 and greater than 0, we give an example is half. Fx equal half power x. So you can see when x equals 0, so it will be 1. When x equal 1 is half. When layer equal 2 is 1/4. If 3, 1/8. The bigger this data, more close to the 1/4, 1/16, right? So the data is, you can see the data will be more close to 0 here, right? So very close touch. And when like a -1, you can see -1 became 2. When a -2 became 4. So you can see this one is growing like this. So this is half. If the base is a number between 1 and 0, 0 and 1, layer is increasing, like decaying. We call it decaying. So we can extend it a little bit. So limit, did you guys learn limit? When x very close to infinity of this limit. So you can see limit. When x go to the infinity, this one equals 0. That's the come from, right? When it continue moving down, it can never touch 0, but very close to 0. So limitation will be 0. So when go to infinity, it's actually 0. Right? Okay. Let's see if layer. So if layer x, the a is greater than 1, less than infinity, I mean just greater than 1. So we'll give an example is f power is this one, a is 2x. So when x equals 0, it's also 1, right? When then x equals 1, it's 2. 2, it became 4, right? Dramatic increase. When the -1 is half, -2, -2. So it's like this. So it's like exponential increasing. This is increase, dramatic increase. Oh, actually here is already drawing here. It past 0, dramatic increase. So this is decay. This is increase. Two different cases, right? So the total depends on this base. The base number is less than 1. Between 0 and 1, they will decay. Greater than 1, they dramatically increasing. Right? So some of just like exponential functions, sometimes they add additional some additional number here, constant number in front. Sometimes they use k. So be careful about this part of cancel expression. Let me see this one. Say, yeah, this like his expression is fx equals k times a power x. So this one is the base. You can imagine like this one decaying. If they have additional time k, something k is, for this example, if 3, k here is 3, right? So will it be times 3 equals 3 here and decrease. So initially it's 0, 1, and here became 0, 3. So will it be like initially is a little bit higher. So you can go down here. So we just like give another question here. So limitation, if here has 3 times, here equals what? Did you guys know what here is equal what? It's what? It's 3 times 0? Still 0, right? So what you can see these kinds of things, you keep decaying. They pass 0, 3 and continue decaying down. Yes, here is 3 over 2, right? Here is 3 over 4. And when they go limitation, they're still close to 0. Go far close to 0. It's not, this means this 3 can put front. So if this is a constant number, you can put a front. Like say 3 times here, so this one can move to the front. So limitation part. Have some rule here. It's a constant number, this one can bring front. Okay. So this one is expulsion rule. Expulsion rule, we SAT definitely have one question there, but it's a very easy question, right? Like this one. All right, let's go ahead and clean the screen. See this one. All right, say in the chart below, each expulsional rule represents a population of bacteria in porridge dish as function of time in hours. As T0, the population dish 1, and the population initially is 2,000, and the population dish 2 is 3,000, right? So here is 2,000 is right here, 3,000 here. So here is 2, dish 1 is D1. And with the time growing, so you can see that this one grows faster, right? So after 1, it grows to 3,000. After 2 grows to about 4,500. 3, it grows to 7,000. It's just like somewhat double, right? 2,000, somewhat double. This you can hear is increasing 1,000 here. Increase what? Increase. I don't know what's the description here. That's somewhat like say, somewhat like the increase 4. It goes up to here, and dish 2 grow a little bit smaller, but slower, but it is still exponentially increasing. And go to the time 4 goes up to 6,220. So let's see what's the question here. At the time 0, the numbers of bacteria in dish 2 is what percent more than the number of T2? In the dish T0, 0 is this 3,000 here, 2,000. So dish 2 is 15% more than dish 1, right? What percent more? So 3,000 divided 2,000. So you got 150%. So how much more? So only 50% more, right? All right, so find the average growth of bacteria dish 1 in dish 2 from time 0 to dish 4. So average growth rate. The dish rate is if they average, actually they are exponentially growing. So if they average here, it became linear line connection of these two, right? So you can just use the dot here and dot here to define the slope. So here is 0, 2,000. That will be easy for you guys. I believe you guys can do it. When this is 0, 3,000, right? And this dot they already told you, so you can find the slope. The slope is the average growth. Right. So actually they describe exponential function, but they didn't use the exponential knowledge. They just give the basic concept here. They didn't use actually exponential knowledge. Okay, let's move on next one. So this part is decaying, right? It's decaying. You can see initially a little bit the base when they go 0, they are a little bit different. Right? One is 25,000, second one 30,000, and they're decaying. And when you go to year 6, they have the same numbers. Right? So they basically just ask how much percent difference between A and B. I believe you guys can handle this one. It's not so good related to the how much exponential change. They didn't use the exponential rules about product, about quantum and factor power rule. They do not have it, so that will be easy. So the question here, so you can check each of them and then get answers, right? Okay, let's go on. Oh, so this is what we talked about. So I jump in this one. Let's go to the question here. Let's see, I just put ABC. Okay, so A, Mark. Let's check this one. Did you guys finish this one as a homework? I assigned this one as homework. I just like to know if you have you guys feel this challenging? Nobody answer me. All right, let's go through here. A, Mark invests 1,500 at the rate of 6% interest rate compounded annually. Compounded means every year base was changing. If they didn't say compounded, every base is the same, 1,500. So compounding means every time growing, the base was changing. How much is the investment worth after 5 years? So this one, so initially 15,000. So first year, right? So the first year time here. So first year is time 1. Here is 1 actually. The second year time became this one became 2, right? So the changing this part was not changing, the base was not changing, the interest rate was not changing. The changing is here. So you can build a relationship is here is x. So function x. So when x, so 5 years later is x is 5, right? So you could have 5. So equals with, don't know, my screen not be right properly. So here became 0.06 power 5. So needed some calculator. All right, help you. All right, so part B. So question B, the price of new automobile is 28,000 if the value of the automobile decrease. So it's decaying, decrease 12%. So how much left? 88%, right? So each year just 88% of previous year. What the price will be automobile after 5 years? So decrease 12%. So it means still have 88%, right? So it's 1 minus 0.12. Power x here is 28,000 initially. So function is here. So x, so after 5 years, so it means x replaced by 5. Right, so it's decaying. Be careful about this one. It's not exactly use 12%. Here rate is not used exactly 6%. It's actually 1 plus here, right? So it means each year you keep the base, add the interest part. All right, let's see the question C. The population of a Western town double its size every 12 years. So every 12 years, so x, suppose a year, divide 12. So how many 12 years changing? Its population will double. Double initially population is P0 times the full power, right? It's in here, function x. So population initially, so every 12 years it can double. Every 24 years, it means initially 4 times of the first year. So if the population of the town is 8,000, so this one replaced by 8,000, right? What of the population will be after 18 years from now? So 18 years means 1.5 times 2, 18 over 12. Right? So it became 8,000 and 2, here 2 over. So here, obviously, you needed to use some calculator to help you get the answers. Any questions? No. All right, let's move on. Let's move on. D. The half-life of carbon. Half-life. So this is basically we met this kind of situation, just like one elementary layer decayed. The weight became initially half after the period called half period. So carbon-14, half-life of the carbon-14 approximately 6,000 years. So that's why, this is methodology. They check the carbon 14 in our soil to check the years how this Earth. This is a methodology in geometry try to find out what potentially the year change several thousand or several million years ago in the area. They use this try to check these kinds of number changing. Carbon 14 normally is carbon 12, right? Carbon 12 is a lot. It's really confusing you. But carbon 14 is a typical. It's a very small portion in the carbon, just like all kinds of carbon. 99.9% maybe is the carbon 12, but they have small portion is carbon 14. They decaying like this way. So you can, based on the change in define the world changing, just like the trees, they grow every year, they grow a circle in the center, right? So based on the cross section of the trees, you can judge how old of this tree. Same methodology, right? They find out this methods. We use the math tool to solve the kinds of problem. All right, so half-life of carbon 14 is approximately 6,000 years. How much 800 gram initial of the material will remain after 30,000 years? So the weight, the final weight actually related to the year, right? So initial weight in half means, so here we'll not use 2, right? Use half. And how much of the year? 6,000 years. So every 6,000 years, they became half of the initial weight. Right? So when now this x replaced by 30,000, so 30,000 here, x replace 30,000. So 0 times 5. So it's what? So you guys know this one, right? 2 power 5 is 32, right? M0. Here M0 is 800 gram. So will be changed to what? So we can just get it. AR 104, so 25 gram. 25 gram left. Something like this decaying. All right. Explosion rule. Okay. Anyone have question of the previous one? No? Okay. Let me go down. I think this is the last one. Right. Last question of last week's. We didn't finish it, so that's why I spent a little bit more time here. A house bought 10 years ago for 150,000 was sold for 240,000 this year. So it's bought 10 years ago, it's 150,000, and right now grows to 240, just like your house. Just like 10 years ago, we buy it, and right now price increasing. You make money, right? They will say, which of the following equation can be used to solve the annual growth R of the value of the house? Okay, so just like say, initially the function is actually just like 10 years. So right now it grows to $2,400,000, right? Initially is 105,000. So they call yearly, annual, just yearly. So each year changing. So we based on yearly, just say price initially is 5K here. Okay, right? Time. So each year we grow R, right? Just like earlier, they have interest growing, and then based on X. So right now, F year is 10. Year is 10. This one equals 240,000. So 1 plus R power 10, right? Power 10. Okay. So we needed to know what R will be. Is it correct? All right, so which one is exactly the same as what we drawing? This one, right? This one. The answer will be C. So it means this one just like interest rate. This one is towards 10 years. The here need to be right like this way, a little bit better. Sometimes they describe it as use this kinds of description. Okay. We didn't know the number where it come from. Right? Okay. All right. So this is last week. What are we learning? Let's jump to our challenge part of your homework. Did you guys finish them? Everyone, did you guys finish them?
Yeah.
Oh, it's very challenging for you?
A bit.
A bit.